So I just took the liberty of setting up this whole problem already. So the mass of this is 1,200 kilograms, right? It's traveling at a velocity of 17 meters per second. The driver jams on the brakes and the car slides to a stop. That means that the final velocity of the problem is going to be 0 and that the coefficient of friction is 0.89. So again, step 1 is always making sure that you break this problem, strip it down for its parts, and write everything down on the right-hand side to keep yourself organized, all right? Part A of the problem is asking for you to draw a free body diagram, which is just, you don't have to use a block. You could put a circle, you could put whatever you want. You could actually draw the car if you want to, it doesn't matter. But it's really just about being able to label the forces acting on the object. Right now I've indicated that it's traveling to the right at 17 meters per second, and then it's going to have to come to a stop within a certain distance, right? So I've written all that on there just to keep myself organized. So part A is already done. This is the free body diagram. Part B is going to be an acceleration problem, and it's the same thing you did on the last one. It's just going to be kind of in reverse, right? First thing you're going to do for that is you're going to calculate the force due to gravity. The object is equal to the mass of the object times little g. Fg is equal to 1,200 times 9.1. Force due to gravity is equal to 11,772 on the nose newtons. Okay, I told you just box that out. That's why you know that this is the force of gravity section of my work and I don't get disorganized, all right? I'm gonna change colors on my pen to do the next part. Now I wanna know the force of friction because I need that as well. So force friction is equal to the force of gravity times the mu. Just as a note, sometimes this formula will say force of friction is equal to force normal times the mu. That's really important, and I'll explain that in a later video. But for now, we're just going to go with force of gravity, right? Force of friction is equal to the force of gravity, which is 11,772 newtons, times the mu, which is 0.89. So again, as a reminder, this is 89%. This here is 89% of this, because that's all you're doing. You're multiplying the force of gravity times the mu value, which is giving you 0.89, which means that you're going to get 89% of the value. So the force of friction is equal to 10,477.1 newtons. And again, you're going to box that out so that we keep ourselves organized. I know you're a Mets fan, so I chose orange and blue here for you. I love the Staten Island Ferry, so I chose orange and blue for myself. All right, so force of gravity, I got to fill up my form here, is 11,772 newtons, and my force of friction is 10,477.1 newtons. All right, so next thing you're going to do is institute Newton's second law to calculate the acceleration. There's other ways to do this, but I always find this to be the simplest way. Some students get caught up in the fact that they have to fill in the formula backwards, but you can just reorganize the formula if you want to make it easier to remember. I just always say F equals ma because it looks like FEMA, and it keeps me organized that way. All right, so 10,477.1 newtons is my force of friction, is equal to my mass of 1,200 times A. So you're going to divide by 1,200, divide by 1,200, and you're going to get A is equal to, oh, you bastards, they did this on purpose, 9.81 negative meters per second squared. So if you followed everything right, they gave you a known value here, and that has nothing to do with gravity. The acceleration that we calculated here, they gave it to you on purpose to show that you can get the same acceleration in other directions as well. So you're getting basically Earth's gravity pulling backwards on this thing, although it's not the force of Earth's gravity, it's just the force of friction, okay? And so we need to figure out how long it took for this object to come to a stop. I know that that's not being specifically asked for, but I'm going to write time to stop is equal to blank seconds. And what I'm going to do here is I'm going to use the VF is equal to VI plus AT formula that we used yesterday, the other question, to calculate the distance to stop yesterday. So my velocity final in this case is 0 meters per second. My velocity initial is 17. And my acceleration is negative 9.81, and we're solving for time, okay? So zeros on that side. What I can do here is subtract 17. 17 is equal to 9.81 t, and 17 divided by 9.81 is 1.73 seconds. So the total time to stop is 1.73 seconds. All right, so now that I have that information, I can go ahead and calculate the total distance to stop. And we will go ahead and use everyone's favorite kinematics formula, DI equals, it's not DI, it's just distance. Oops, come on, erase. Come on, continue to erase, there you go. So distance is equal to velocity initial times time plus 1/2 AT squared. Or a much easier one is D is equal to VI plus VF divided by 2 times time. That's a much easier problem to solve. And so basically what you're saying here is this is my initial velocity of 17 and this is my final velocity of 0. So I'm adding those two together and I'm dividing them. Where have we seen that before? Well, that's just the average, right? So you're taking 17 and 0, you're adding them together and you're dividing by 2, and that gives me 8.5. So D is equal to 8.5 times the time that we calculated, which is 1.73 seconds, and times 1.73 is equal to 14.705 meters. So the total distance that this thing traveled is 14.7 meters. So this is 14.7 meters. Okay, any questions, please let me know. I can send you more videos if you want. If you have any specific questions, just send them back to me and I will create a new video to answer those questions.